Hey, I bet you everyone's got a module like this lying around. Something that you reopen every couple of months. Someone applies some fixes, does a cleanup, fix, bit of a refactor. But it sort of happens every few weeks. And if you're lucky, you're not back at it next week, but it will be next month, if not next quarter. And it'll be another chance for a big refactor. Here's the strange part. When we see stuff like this, framework's often current, the tests are all passing, the type check is happy. So what's happening? We're up to date. The tools are helping us. The tools tell us good, but there's pain. It hurts to be in and around this code. So every tool says the code is good. Why doesn't it feel good? Well, because none of the tools are measuring the stuff that hurts. So let's name it. Application architecture is a deliberate control of 6 forces: change, coupling, meaning, testability, failure, and evolution. Change is when something else needs to change with you. Coupling is what's tied to that. Meaning is whether the code knows its values, what its values actually are. Testability is whether you can test logic on its own, or do you need to stand up a web server and a database just to test a bit of logic. Failure is what happens on the unhappy path, and evolution is whether this thing can grow without a rewrite. That's the whole subject. It's not a diagram, it's not a framework. Application architecture is about managing those 6 forces. Now, why doesn't your tooling catch this stuff? Well, your tooling only ever promised you 4 kind of guarantees. You've got language, framework, tooling, and the team. The language is going to check the shape and syntax of your code, check that that all fits together. The compiler is the one that does the work here and gives you the thumbs up. The framework is checking that it guarantees the wiring. Have you got a router, your lifecycle management? Have you got controllers and request handling managed? Tooling guarantees what you bolt on outside of the language. So your CI gates, your schema validation, your runtime validation, test suites. And then there's the team, the conventions that only people can enforce. But here's the catch. The first 3 are real, but each is narrow. The only guarantee that's wide enough to carry all 6 forces is the last one, the human one, the non-deterministic one, the one that forgets stuff, the one that can leave, the one that ships on a Friday. So a guarantee tells you what something or someone else has already checked. A force is what you have to protect yourself against. So leave those forces unattended, and this is what happens. You can't talk about them. You end up having these kind of conversations. We've got a nitpick, the loop style nitpick, the rename nitpick, and the maintainer applying, please don't nitpick, which is fair enough, right? This is a real review of a real problem. Look at where the comments land. Variable names, whether this should be a const, someone else's opinion on early returns. What's not covered here is that the file's over 1,400 lines long. It's got over 60 branch conditions and over 20 loops happening in this file. So we're not focusing on the structure, we're focusing on the paint. Let's jump back and have a little look. We're down to line 900 and no one's called that out yet. Is this file too big? We've added new things in. No one noticed that we're actually changing things that are unrelated to this pull request. The problem is the review spent its whole budget on the paint and never touched the structure because the team had words for the paint and had no words for the structure. That's the cost of missing vocabulary. Pricing arguments masquerade as design arguments. Style wins because style is the only thing that everyone can name. And when you can't name the force, you argue about the paint. So teams go looking for vocab, and there are 3 common places you can look. You can look at framework conventions, reference architectures, or forces and guarantees. So 1, we can adopt a framework's convention. The Nest way, the Rails way, the Spring way. You let the framework hold the opinions, and there's a folder for controllers, folder for services. You follow the map, and for a while this genuinely helps and everyone's code looks the same. Number 2, you adopt a reference architecture, clean, hexagonal, onion. You take a canonical picture off the shelf, the concentric circles, the dependency arrows, and you arrange the code to match the diagram. Number 3 is you can adopt a force and guarantees lens. This is the one that we're going to be building up on this video series. For each piece of code, you ask 2 questions. What does this protect? We're trying to name each of the 6 forces. And which guarantee am I leaning on? Is it the language, the framework, the tooling, or just hope? The first 2 of these, the framework conventions and the reference architecture, they hand you answers. The third one, a forces and guarantees lens, hands you a question. And the difference between an answer and a question is whether it still works when your situation stops matching the source material. So, because each of these things costs you something, let's be honest about all 3 approaches. The framework convention buys you a shared shape fast on day 1. They cost you the day your problem stops looking like the framework's assumptions. So you're leaning on this thing because of these assumptions. When they no longer hold, your framework doesn't really hold either. The convention quietly stops helping because it was never about forces, and nobody can say why it stopped being valuable. Reference architectures, on the other hand, buy you a portable picture and a shared word like port or adapter, but they cost you context. The diagram never tells you which force is under threat here and in your service. So teams copy all the layers, including the ones that they didn't need, and they call the ceremony architecture. The forces lens buys you something portable that can also fit in your context because you derived it from your context. The cost is real, and I won't hide it. You have to do all the naming yourself, right? The diagram won't do it for you. And that's the tax this series asks you to pay. I'm not going to tell you that one of these is the right architecture. There isn't one. There's the move that fits the force in front of you. You can only see it if you can name the force. All right. So let's jump in and do exactly that. Let's start naming some forces. Let's jump in and look at some code. 1 file. I'm going to change nothing. All I'm going to do is name the force each problem threatens. And that's the move. Right. So this is an order service. It takes a request, it prices it, it saves it, and it emails the customer. So first thing I want to point out, it has 4 jobs. We've got validation, we've got pricing, we've got payment, persistence, notification. There's 5 things in there, but pricing really is the core feature. So we're validating, we're managing payments, persistence, and notifications. Right? 4 separate reasons to change in one place. A tax rule change and a database change now open the same file. Let's name the force. Change. Now let's look at the order type up here. So we've got an order type, but notice that we've got the ID and __v, the version number. Those aren't our domain. Oh, and a created app. Not sure if that belongs in our domain either. They've leaked in from the database, and the service reaches straight for the database. The domain now can't move without the database coming in with it. Let's name the force, coupling. Next, we've got customer ID and email. Both are strings, right? To the compiler, those are the same type. You could pass one where the other belongs and nothing would complain. The compiler is happy. The architecture is not happy. Name the force, meaning. Now we're going to come back to this one later when we talk about types and whether they protect you or not. Right, now we've got a discount rule in here. Here we go. If the line items add up to over 100, we can give you a 10% discount over $100. Nice. To test that one rule, however, I have to boot up persistence and run the whole pipeline. If I need the database to check a price, the design is the bug. Let's name the force. Testability. When payments decline, we throw a naked string. The failure path is invisible to the type system. Nothing downstream knows it can happen. Let's name the force. Failure. And finally, the channel, which we do notifications on, is hard-coded to email. If we want a new channel or a new payment provider, that's surgery on this class. It's not an extension of it. Name the force. Evolution. Now, I haven't changed a line here. I've just given every problem its real name, and that's a job today, a job you can do tomorrow in your review before you touch anything. So frameworks can come and go. Diagrams can stall on context, but what's left when the tooling is finished agreeing with you is the set of forces you choose to protect on purpose. So here's the move. Tomorrow, I want you to, in your next review, before you suggest a single change, name the forces. Architecture is what you protect on purpose.